Hi, my name is Evelyn, and for my spring final project on the topic that I chose was on the movie Up. And I chose the movie Up because I've always liked that movie ever since I was a kid, and it's a nice fictional movie. So, for the first problem, Carl has to fill enough balloons for his house using 15 liters of helium per balloon, and since he needs 1,400 liters in total, the time it takes is modeled by this expression right here. And so we're gonna expand it. So for the logarithm, the expression is right here. And for the first step, you need to rewrite it. So it's log 10, and then in parentheses, t to the power of 15 minus log 10, 1,400, and then 1/2. And for the second step, you need to put the 15 in the front. So plugging that in is 15 log 10 t negative or minus log 10 1,400 and then 1/2. And we need to do the same for the 1/2, put it in the front. So the final answer would be 15 log 10 t negative or minus 1/2 log 10 1,400. So Carl has a time expression of 15 log 10 minus 1/2 log 10 1,400, which shows how long it would take him to fill all the helium balloons. So the second problem is if Carl had 10,000 helium balloons and together they contained a total volume of 3,000 cubic feet of helium, how much buoyant force, which I think that's how you say it, would be generated to lift his house? So the buoyant force formula is FB equals PA minus PG times G times V. So the meaning for those variables is for PA is the density of outside air, or just density of air. For PG is the density of gas inside the helium balloon. For G is the gravity, and for V is total volume of gas, which I picked 10,000 balloons, and the FB is just the buoyant force. So for PA is 1.204 kilograms per cubic meter at sea level. PG is 0.18 kilograms per cubic meter. G is 9.8 meters per second, and V is 3,000 feet. But as the V needs to be in cubic meters, I need to convert it. So 1 cubic foot equals 0.0283168. So times that by 3,000 is 8495. So the volume of gas is 84.95 cubic meters. So it's really easy to solve it. So step 1 is we have to plug it in. So FB and then parentheses 1.204 minus 0.18 times 9.8 times 84.95. So step 2, we have to subtract the density. So 1.204 minus 0.18 gives us 1.024 for the FB. So then we plug it in. So FB equals 1.024 times 9.8 times 84.95. So then we multiply by the gravity. So 1.024 times 9.8 gives us 10.04. So then we plug it back in, which is FB equals 10.04 times 84.95. So then we had to multiply by the volume. So 10.04 times 84.95 gives us a 52.90. So Carl's 10,000 helium balloons would generate about a 52.90 newtons of upward buoyant force, meaning that can only lift 192 pounds, which can't lift a house. So